There was a famous mathematician, John Horton Conway. So he was also interested in many things in mathematics. If you just Google on Conway, you will find thousands of websites devoted to what Conway has done. He was also interested in these symmetry and phrase groups, and for phrase groups he developed these footprint motif and also gave them some nice memorable name. So, if you hop on one foot, in this case the left foot, so somebody is hopping on left foot with black paint on it. So, we will leave footprints like this. So, what is its symmetry of this hop print? What is it?
Translation.
Translational symmetry. Very good. So, anything other than translational symmetry is represented by lattice. So, if we select a lattice point and you know that lattice point is really your choice, the pattern only dictates the translation, that after what distance the lattice points will repeat. But where you begin your lattice point, what point you consider as a reference is of course your choice. So, in this case let us say if we select maybe this gap as the lattice point. So, all these points are translationally equivalent and a distance from one to other is the lattice translation vector. So, there is a translational periodicity. Any other symmetry it has? Does it have a mirror plane or a twofold? Twofold is there? So, it has no symmetry other than translations. So, that is one kind of pattern, and remember we are talking of Fries groups, Frieze, Fries groups, which are space groups of two dimensional patterns. So, footprints are two dimensional pattern, but with only one dimensional periodicity. So, Fries groups are 2D patterns with 1D periodicity, and we had started looking at it, and we had looked at some beautiful patterns, border patterns in the last class, and we saw 5 of them, but we had claimed that there are 7. So, these are examples of space groups. You can call it space groups because they are combination of translation and point symmetry like rotation and reflection. So, it is a special kind of a space group. When we talk of a space group without any qualification, we essentially mean 3-dimensional space group of crystals with periodicity in 3 dimensions. So, the object is also 3 dimensional, crystal is 3 dimensional, and periodicity is also in 3 dimensions because it repeats in all 3 directions. But in Fries group, first of all the object is not 3 dimensional but only 2 dimensional, and even 2 dimensional object can have 2 dimensional periodicity like in floor tilings or wallpaper. But in Fries group, although the pattern is 2 dimensional, but translation or periodicity is only in 1 dimension. This is what you are seeing, and this particular the hop pattern is having only translations, and that is a minimum requirement anyway for any periodic pattern. Then the second one Conway has called spinning hop. What do you see here? What kind of symmetry? Twofold and translation. So, if we consider, let us say, let me identify the twofold. So, if we let us say join this thumb to this thumb and this heel to this heel, the intersection point will define the two-fold, and similar thing will happen in the next motif. The two-fold will repeat. It will repeat with the, because the pattern has translational periodicity, the pattern repeats by this distance. Translational periodicity. So the two-fold also will generate, unless and until two-fold also repeat by the same distance, you will lose the translational periodicity. So the two-fold also is getting generated at this distance. But is that all?
Inversion, sir.
Inversion where?
Sir, around two-fold, if we kept z as 0, then x, y, z goes to minus x minus y. That should be
So, and what does two-fold do?
same.
Same. So, in 2D, that is an interesting point you have raised. So, let us make a note of that. In 2D, the two-fold and the inversion are the same. They are not distinct operations. Whether you say invert in a point, which is so, just like you were saying, that I have suppose I say that this is an 1 bar point, this is an inversion center. So, what will it do to any vector? Any vector r, it will rotate, sorry, it will invert to minus r. But now I say, I do not think of inversion operation, but I think of a two-fold rotation operation. So, it will rotate this vector by 180 degree and will again give you the same minus r. So, whether two-fold or whether inversion center acting in 2D have exactly the same effect, same mapping, point to point mapping is exactly the same. The matrix if you write, so the matrix you write by looking at what it is doing to 1 0 and 0 1. 1 0 it will invert into bar 1 0 and 0 1 it will invert into 0 bar 1. The two-fold rotation also will take 1 0 to minus 1 0 and 0 1 to 0 minus 1. So, their matrix also is exactly the same, mapping is exactly the same, only our thinking is different. In one case we are saying that we are inverting, and in another case we are saying that we are rotating by 180 degree. So, crystallographers have decided to exclude 1 bar from the notation in 2D, and in 2D we only use the two-fold. So, if you have two-fold, yes, you have inversion center trivially there. So, we will not count it as another symmetry operation. But is that all here, or we are missing some symmetry in the spinning hop? So, spinning hop, see, I think Conway is imagining is still hopping, because nobody will have his 2 feet like this unless and until it is some devil or that 1 foot backward and 1 foot forward. So, he is imagining that you are still on 1 foot, but you are spinning and jumping on the other side, and then again you jump. So, you are doing a hop and a spin. So, spinning hop. So, is that all the symmetry in the spinning hop?
Two-fold in the middle, two-fold in between.
Two-fold in the middle. What we are missing is that if we join this thumb to this thumb, or this big toe, I think, and this heel to this heel, you will find that there is a two-fold there also. Let me use a different color to show that twofold. So, you have a green twofold there, and last class we had tried to prove this also, I think. Since I am myself forgetting that whether I had proved it or not, I can excuse you for forgetting what was the content of that. That whenever you have a combination of a translation and a twofold rotation, you will generate a twofold not at the translation distance, but at t by 2. So, let me say that twofold at origin, combined with a translation t is a twofold at t by 2 away from the origin. So, this probably is a nice operator symbolism we can say. So, this will always generate. So, in any pattern where you have twofold and translations, very important result, and you will see the repetition of this. In any pattern where you have a twofold and a translation combined with that, you will find that actually twofolds are appearing at half the translations, and those two twofolds I have given different color here. From pattern wise also, if you see, they are differently located with respect to the pattern. So, here you can see that the red one is between two vertically shifted footprints. They have footprint just above and below. The red one has footprints above and below. The green one does not have footprints above and below. It is shifted to the left and right. So, in the pattern they are also playing different roles. Both are twofold. See, if you try to take a mirror image, now these footprints are difficult to draw. So, but suppose I put, you want to put a horizontal mirror or vertical mirror? You want to put a vertical mirror. So, let me put a vertical mirror here. Then if I can draw, now my drawing skills are being challenged. Somebody good in drawing should do this. Maybe something like this you will get, isn't it? You can see that none of the footprints are in this orientation. Okay, none of the footprints here. You have two variants, but you don't have this variant. Okay, that the curvature, the curved side or the deeply curved side is upwards and the toes are on the right. So, whenever the deeply curved side is upward, like in the lower row, the toes are on the left. So, you do not have a mirror image, you have only a rotated version. The mirror image is this. So, in this case you do not have left handed and right handed or left foot and right foot, both are actually left foot only. That is why it is still a hop. You are hopping still on one foot, only you are spinning, so it is rotating by 180 degree. But yeah, hop is at hop or a twofold will be a type 1 operation. So, it cannot change the handedness of the motif.
For example, we take rotation, translation, inversion. I mean, do these operations have something fundamental property that they cover anything else, or is there anything else possible that we define a new operation and then include that into symmetry group?
Say that again.
So, for example, inversion is something I define a new operation which does not exist, and then take that symmetry corresponding to that operation also into the symmetry group.
Yeah. So, I think the current list of symmetry operations is complete. That is one that we made for crystallography. For crystallography we said that we are limited to 1, 2, 3, 4 and 6 because translation was not allowing 5 and translation was not allowing higher one than this also, and then 1 bar, 2 bar, 3 bar, 4 bar and 6 bar. So for, and we said that of course there is translation. So this list is more or less complete except for the fact that we have not considered screw and glide, which I have been mentioning here and there, but have been avoiding discussing this screw and glide. So if you now after years of work and thinking and all, this list is supposed to be complete. That is, you cannot think of a new symmetry operation which cannot be described by these. It will be, if it is, and I think there are, just like we gave a mathematical proof that for lattice translations, for periodicity, no rotations other than these are allowed. So similarly you can give proof that no other symmetry operation can be present other than these. Okay. There can be composite operations. So for example, you can combine a screw rotation to a glide reflection and will get something new, but that is still, the components are known. You can, that we anyway know, that if screw is the symmetry of the crystal and glide is also a symmetry of the crystal, then the space group is just again the symmetry group, and by the closure property of the group any combination of the operations have to be some operation. So it may appear new at the first sight, some combination may, and translations are infinite, rotations are finite. So you have only finite number of rotations, but translations are infinite and they are at various angles in 3D. So I can have a rotation about this axis and can think of a translation at some angle, and what will that give. So it may give something which may appear to be new at the first sight, but then it has to be a combination of my list of group elements which I have listed, if it is satisfying the group property. And since it is symmetry, it has to satisfy the group property, because by very definition of symmetry we are demanding that the object is left invariant, comes into self coincidence. So if one operation brings it into self coincidence, another operation brings it into self coincidence, so the combination has to bring it into self coincidence, one followed by another. So we do have, means I think your worry was probably here that 2 bar became, 2 became 1 bar, is that how do we know whether we are having a new one or an old one in a new garb?
Main question was why we are only taking this subset, for example, roto inversion, rotation and so on. Why not all other possible operations?
We are taking all possible operations. We are restricted to rotation and roto inversions only because translation restricted it to these. And it's a good question. I think we have not answered this.
Roto reflection we have not taken. Maybe that comes out to be combination of
yes. So roto reflection when we considered, we showed that each roto reflection is corresponding to some roto inversion. So, we found nothing new, so we gave up or we accepted. So, and two schools of initial developers came. So, Schoenflies for example, who is a famous crystallographer, and one notation is Schoenflies notation. So, he took rotoreflection, he did not consider rotoinversions, but later on when these international tables people came, they considered rotoinversion. But in the end, just like in the 2D case, two-fold is becoming one bar, in 3D you know that one bar is two-fold rotoinversion. In 3D one bar is not 2, in 2D one bar is 2, but in 3D one bar is two-fold rotoreflection. That turns out to be the same, means if you suppose you have an object here at R, inversion will take you to an object there of a changed handedness, right. If you do a two-fold rotoreflection, so you will first rotate by 180 degree to bring it here, handedness will not change, and then you will reflect, and you will find that you reach exactly the same place again with the turn, with the reflection. The rotation did not change the handedness, but the reflection will change. So, what you are showing that one bar is two-fold rotoreflection. So, our naming will change depending upon our preference or something, but in terms of mapping we are not getting any new mapping, the same point is being mapped to the same point in exactly the same fashion. So, yes, all these worries were there, but your question is still little deeper, which we have not answered, and probably assuming it to be true or taking it for granted or brushing it under the carpet, whatever you call it, is that what we are requiring, demanding is symmetry. Symmetry does not change distances, that is one big restriction, because otherwise if you think mathematically of mappings, mappings can distort your object also. Means if you deform a ball into a cube, that is also mapping each point of the ball to some point of the cube, but there the distances will change. So, the first requirement of symmetry is that it is an isometry. Isometry means distances are not changing, and the second requirement is that it is an isometry which maps the object to itself. So, an isometry which maps object to itself is a symmetry operation. You can then show what you are demanding and we have not done is that now if we say that this is the only requirement, what all possible mappings are there in 3-dimensional space or in general in n-dimensional space which will satisfy these two criterion, that it does not change the distances and it maps the object to itself. So, and I think that sort of mathematical questions are also answered. We have not taken that route and sort of have just assumed that these are the operations. For each operation I know, that it is not changing the distance and it is mapping the object to itself. So, that we are verifying, but we have not given a proof that these are the only operations and we have exhausted the list. This is what you are demanding. Okay. So, we can look it up. I hope that there are theorems and things to prove that in more mathematical texts we should be able to find it. Yeah. So, now let us come to jump. So, here both foot are there. So, you can see now the left foot and the right foot both are there. So, obviously there is reflection, horizontal mirror. So, in jump we have a horizontal mirror, and of course the translation anyway is there. But now the two-fold rotations are not there because the upper foot and the lower foot cannot be related by a rotation, because there is a change in handedness, and rotation will not change the handedness. As soon as you will rotate, you can see, compare it with the spin. As soon as you will rotate, the foot will start pointing on the other side. Instead of forward direction, it will start pointing in the backward direction. The only way to keep both foot pointing in the same direction is to reflect in a horizontal mirror. So, but then if you reflect, the left foot changes into a right foot. So, that is the jump. So, this is translation plus I can say a mirror which is parallel. So, a parallel mirror. Then of course, he has to generate a vertical mirror also. So, for that you will have to do a sidle. So, you have a mirror. Translationally equivalent mirrors are here, but again identical theorem, and these you can prove by Sites notation, which we have developed. So, mirror also gets generated. So, actual lattice translation is T, but mirrors will be repeating by T by 2. This will always happen. There is no violation, and you can see it by using the matrix. And Sites notation. Then of course, there is this interesting spinning jump. So, you are having both foot on the floor, but you spin and jump. So, the next time you are pointing, after jumping, when you put your foot down, you are pointing in the other direction. So, what do you have here? So, you have both vertical and horizontal mirrors. Anything else? Some more mirrors, T by 2 mirrors. And where? Now, this is again something you can prove. Yeah, whenever two mirrors are intersecting at 90 degree to each other, the line of intersection of the two mirror has to be a two-fold. So, I leave this as a homework again for using Sites notation, or you can use it simple geometry also. I think we had done this in some of the earlier class. So, if you have, let us say we have two mirrors, and let us play with a motif here. So, the mirror, the vertical mirror will generate another motif of a different handedness. Then both of these will reflect in the horizontal mirror. And handedness will once again change. But now you can relate the object of same handedness by a 180 degree rotation about the center. So, you can see that is a two-fold. So, that is your spinning jump. So, here we have, here we had translation plus perpendicular mirror. Now, we have translation plus perpendicular mirror plus parallel mirror and the resulting 2 folds. So, this seems to be the most symmetric, and we seem to have exhausted our ingredients, because in 1D translation, because we have to preserve the line, I have no other rotation than 2-fold, because I want to bring the line into self coincidence. Whatever I do, I want to bring line into self coincidence. That is the definition of symmetry. And if I have a line, and if I give any other symmetry operation, 30 degree, 60 degree, 90 degree, I get a totally different line. It cannot come into self coincidence. So, the only symmetry operation which was available to us in terms of rotation was a 2-fold rotation, and mirror was available, but again mirror was available only in 2 specific orientations, either a perpendicular mirror which will reflect the line into itself, or a mirror which is passing through the line, which we call the parallel mirror, which will preserve the line. Any other mirror at an angle or something will tilt the reflected image into some other line. So, these were the things we had. Translations anyway were required because we were thinking of periodic patterns. Then we used 2-fold to create a spinning hop. Then we created a jump using parallel mirror, sidle using perpendicular mirror, and then we combined everything to get a spinning jump. So, 5 different freeze group. So, what else can be there now? Are we missing something? Think of all the things you can do with your feet. You can hop, you can spin hop. Mostly you will not try, but you can try spin hop. It will be a good exercise. Jump, sidle, or a spinning jump. I think it will be good exercise to go back to your rooms and try all these motions. Good symmetry homework. Are we missing something?
Walk.
Normal walk. We are missing the normal walk. So that's where comes this step. In a normal footprint, you will not do any of those natak. You will normally walk like this. So, if you are doing normal walk like this, does it have a 2-fold anyway? See, 2-fold will relate only right foot to right foot and left foot to left foot. The left foot chain is on the top. So, somehow one foot has to be rotated, one left foot has to be rotated to another left foot by a 2-fold. But 2-fold will change the direction of, in the direction in which the foot is pointing. Here all the feet are pointing to the right. If I apply a 2-fold, the foot should be pointing to the left, no foot is pointing to the left here. So, 2-fold is out. Perpendicular mirror can we consider? Now, perpendicular mirror will relate a left foot to a right foot, and again will change the direction in which the foot is pointing. Here left foot and right foot both are pointing in the same direction, so there is no perpendicular mirror. Parallel mirror will change left foot to right foot, and it will be pointing in the same direction. So, here we have left foot and right foot, and both are pointing in the same direction. So, there was a possibility of a parallel mirror, but what happened? The parallel reflection would have come vertically below the foot. So, it is not coming vertically below the foot. So, what is happening? It is reflected, very good. It is reflected as well as translated. So, the most important way of walking actually and we cannot say that this pattern is not symmetric. So, it does not have parallel mirror also. So, since it has none of the ingredients which we started, we declare that this is a non-symmetric pattern, but it does have translation. Translation is there. So, then we say that a step is having the same symmetry as the hop, but that looks little far fetched, because internally we do feel that this pattern is showing something more symmetry than a hop. Even without the lower row, it was a hop with the left foot, or even without the upper row, it was a hop with right foot. So, it does have a symmetry, and this is the kind of exploration and something which your question was pointing to, that how do we know that we have exhausted. Means we could have been satisfied with this, that we have explored everything and we have all the symmetry, and announced to the world that there are only 5 possible Frege groups. But when you look at it, you find that actually you have discovered now a new symmetry, where you are combining a translation with a reflection. So, you have the so called glide plane, or in 2D a glide line, and what you are saying that you will see, you have to translate this by this much to get translationally equivalent foot or translationally equivalent motif. So, that translation is this, but if you translate just half of that and then reflect, you will get this foot. Then translate half and reflect, you will get that foot. Translate half and reflect. So, half translation is going this way. Neither the translation, now the translation associated with the glide operation is half the lattice translation. Okay. So, if you do a half translation, the pattern will not come into self coincidence. You have to do a full translation to bring into self coincidence. So, half translation is not a symmetry operation. If you reflect in the red line, again you do not get self coincidence, because without shifting it is not coming into self coincidence. So, reflection is also not a symmetry operation of this pattern. So, neither the mirror alone nor the half translation are symmetry operation, but a combination of the two is a symmetry operation, and that is what is called the glide operation. So, glide is a combination of half translation plus a reflection in a line containing the translation. So, this step gave you that example, glide. So, this is the 6th one. Finally, now can we combine, now we have found a new thing, glide, but we have 3 old things, two-fold, perpendicular mirror and parallel mirror. Can we combine our newly found glide line with one of these old ones to generate a new symmetry? Can I combine glide line with a mirror parallel to the line? What will happen if I combine glide line with a mirror parallel to the line? We can do, means drawing these feet are difficult, so you can take a simpler exercise. So suppose this is a glide line and you have an object, so you reflect and translate. So you create an object. Since you reflected, you will create an object of opposite handedness. Then you again reflect and translate. So you will get the object of same handedness. Then reflect and translate opposite handedness. Reflect and translate same handedness. So you are seeing the actual translation, actual periodicity of the pattern is this. Whereas for glide, what we were doing, we were giving only half translation. So if we just translate halfway, then I will have to have a motif there which is not there. So halfway translation is not consistent. But now if I want to make this line, glide line, into a mirror line, let us say, I make it a mirror line. So which means the mirror will now create new motif because it has to reflect. Oh, this has to reflect here. And this has to reflect here. This has to reflect here. So you get a plane mirror. So glide means mirror dominates. So glide plus mirror is actually just mirror. So it doesn't give you anything new. What about glide plus twofold or perpendicular mirror? Can we combine glide with a perpendicular mirror? Try it in this way only, the way I have shown you. So create a glide. First create some motif which represents the glide. And you add a perpendicular mirror. What will happen? So these new motifs you will generate, trying to satisfy the glides. So you find that again, just like it happened with the combination of, see, you have put a mirror plane, whether glide is there or not, this mirror plane is seeing a translation, and the translation was of T. So currently the mirror plane which I have drawn is with translation T, because this motif is equivalent to this motif. So that is your lattice translation. So the mirrors are also separated by the same distance, T. But you know, a combination of a mirror with a translation generates mirror at T by 2, which I have not yet drawn. So they come there. My placing is not perfect, but you can imagine that there are mirrors there. Okay. But there is something more. Can you see something more which is relating these motifs? Yeah. Between two mirrors, now two folds are getting generated. When I say two-fold, it's not only for the nearby motifs. Any motif in that infinite pattern, if rotated by that two-fold, any given two-fold will give you an equivalent motif somewhere else in the pattern. So between two, so red mirrors were generated by lattice translation. The green mirrors got generated by that combination rule, that a mirror with translation will always produce you mirror at half translation, and then these blue two folds are also getting generated by some combination rule, means I can't avoid that. I didn't try to create a two fold, I just added this red mirror plane, but effect of adding the red, this is where the space group is coming in. The effect of adding one single red mirror generated an infinitely many red mirrors at spaced by translation t, because I have to preserve translational periodicity. Then a translation in combination with a mirror gives you mirrors at t by 2. So, I get infinitely many green mirror planes, and now all these conspire to give you two folds exactly in between the two neighboring mirrors, between a red mirror and a green mirror. So, you generate a totally new kind of symmetry by combining this newly found glide line with one of the older symmetries, and that is a perpendicular mirror, and that is Conway's spinning sidle. So, if you look at this pattern now, you see these are the vertical mirrors. This is the horizontal glide, and then these are the two folds between the mirror planes. In fact, in my previous, to use the color coding of my previous drawing, I can use green. So, a spinning sidle. So, seventh different symmetry, and there are no more. Now, one can claim that there are no more. Again, without proof, we are saying, just by our intuition we have tried to combine, but by intuition we were ending at 5. Then glide was discovered. We can, of course, we can say that we combine glide with, we can't glide with parallel mirror. That was a trivial case that became mirror. We combined glide with a perpendicular mirror, and we got this interesting situation of a spinning sidle. What about if we combine glide with a two-fold? That is our another masala. But then you can see that combining it with a mirror generated automatically two-fold. The reverse will also be true. If you started with a glide line and combined it with a two-fold, that will generate these mirrors. Even more interestingly, if you didn't have the glide line and you just had combined a mirror with a two-fold not passing through the mirror, that will generate the glide. So, if I have a mirror, I started with a mirror, you can do these experiments, because see, that is why it is important to do the 2D space groups little bit more carefully, because nothing is beyond your imagination, nothing is outside your plane of paper, there is nothing which you cannot draw and see. In 3D you have to imagine a lot, but the 2D cases can be fully worked out with just with pen and paper. So, in 2D cases you can, so what I was saying, the experiment, let us try to do that. I claimed that suppose you did not have the glide, you just had a mirror and a two-fold. Only requirement is that a two-fold is somewhere shifted from the mirror, it is not on the same line. Then you can draw a perpendicular line from the mirror to two-fold and show that this line is going to become a glide. Why? Let us try that. Yeah, start with a motif here, a reflected motif here, a two folded motif here, another two folded motif there. Now a rotated mirror, because if it is a two fold, it will act on the mirror also. Where will it take the mirror? By rotation about two fold. Two fold is there, a mirror is there. If you rotate it, the mirror will go on the other side at the same distance. Okay. So that's exactly where these two motifs are anyway demanding that they are connected by a mirror reflection. Okay. Once this is also a mirror, this will reflect, it will act not only on this lower motif, it will act on this upper motif also. So this will reflect here with changed handedness, this will reflect further apart again with changed handedness, and there will be a mirror again there. You can see now that your real translation from motif to motif is here, but you can also see now that you can take this motif by T by 2 and reflect in this plane to get this motif, and same thing is true for all. So we didn't start with the glide plane, we only started with the two fold and the mirror, but we are seeing that glide plane is emerging. Okay, spinning sidle.